There is a strong relation between centripetal force, acceleration, and frequency. When you go to the home development store nearby, that you find many tools that are called rotary tools or power tools, like the drills and the impact wrench and all those tools. When you look at the box of those tools, the manufacturing company is trying to sell for you a main point or main character for this device, which is the RPMs. How many RPMs can this device spin? Which, of course, in many ways, it means how strong or capable this device is, and based on that, it will sell for you. So since those devices or those tools are rotary tools, that means they are related in way or another to centripetal force, frequency, and cycle, and all those physical properties. When you are spinning a drill, or you have in this case a disc that is spinning clockwise or counterclockwise at a certain speed, the radius of that disc is important. So when this disc is spinning, the circular speed, the frequency, and the cycle of the disc is related on the radius of that disc. Let's say we have a disc over here, that's the center of the disc. We have points A, B, and C at a certain distance from the center of the disc. A is the closest, B in the middle, and C is the farthest away from the center of that disc. Now the disc is spinning about its axis with uniform circular motion and positions A, B, C at different radii from the axis of rotation. But each position of those makes one complete revolution in exactly the same time because they are on the same disk. So that means they have the same period. If the periods for points A, B, and C are the same, that means the same frequency as well. We can generalize that for any solid rotating object, regardless of its shape, the frequency of rotation for all points on that object will be the same. Now, if we compare the speed for points A, B, and C, point A is the closest to the center of rotation and it will have the smallest radius. After that will be B and C with the largest radius. And we discussed that 3 points make one complete revolution. If you want to summarize, it means the speed of a point on a rotating disk will change with respect to its radius or how far it is from the center of rotation. Now let's roll your brain around this topic. If you have the Earth over here, you have the center of rotation for the Earth, you have the equator over here. Now, the higher the altitude, the further you are from the axis of rotation for the Earth. Of course, you are not living exactly in the center of the Earth inside, you're living on the surface of the Earth. So, as you are getting more far from the center of the Earth, your altitude will be higher. And that means you are farther from the center of rotation. As the object is being closer to the center of the Earth, it is slower in rotation. And as the object is the farthest from the center of the Earth, it will be having the fastest rotational speed. We know the Earth have a constant rotational speed as a system, but there is a micro little change between somebody standing near to the center of rotation for the Earth and somebody standing on the equator, which is the farthest from the center of the Earth. In this case, the one on the equator will be moving slightly micro little change faster than the one living closer to the center of the Earth. But at the end of the day, when the Earth complete one day, that means the Earth already completed the 1 day rotation for all the objects on its surface.